Hello, this is Mr. Henry, and welcome to lesson 4.7, Equations in Two Variables. The essential question says, how do I find the solutions and graph equations in two variables? So we'll be doing two things. We'll be actually finding the solutions to equations in two variables and graphing them. The warm-up asks, how do you think solving the following two equations would be similar and different? So I have the equation, one says 3x minus 6y equals 12. The other says 3x plus 6y equals 12, and 30 plus 6y equals 12. So put down your thoughts, what you think. The solving of both of these, if your goal is to solve for y, which usually when you have two variables like this, a lot of the times that's what's going to happen. You're going to be trying to solve for y. So to solve both of these equations for y, you're literally going to do the exact same steps. You're going to, well, for the one you know how to do this with one variable. You'd subtract 30, 6y equals 18, divide by 6, y equals 3. So nothing new there, stuff we've been doing a whole long time now. The other problem, if you're solving for this y, you still treat this other term as if it's just like a number, just like it's 30. It's just 3 times something. You don't know what that something is, but it's just 3 times something. So you want to get rid of that thing. Now over here, you can't actually do the subtraction because they're not like terms. So you just have negative 3x plus 12, and then you divide both sides by 6. And you get something, a little bit uglier. But that's still, it's the same math. We subtracted this thing, we subtracted this thing. We divided by that term, or that coefficient, we divided by that coefficient. We just get things a little bit uglier on the other side of the equation. Okay, so we've got 4 vocab words here. First one is, well, equation in two variables. What the heck is this thing? Well, it's an equation with two variables. Usually it's an x and a y variable. Doesn't have to be, but it really helps us out because when we will get to graphing, we know about the x-axis going horizontal and the y-axis going vertical. So using the x and y variables helps us with our graphing. Standard form of a linear equation. This is the first of 3 forms we're going to learn. Standard form looks like this. It's this ax plus by equals c, where the a and the b are not zeros. So this standard form is one way to write the equation of a line in 2 dimensions. And that's what this is. That's why we have 2 variables. 2 variables means our line is going to be in 2 dimensions. It's going to be a height and width. If we had 3 variables in x, y, z, well, then we would have a 3-dimensional graph. But that's not for this class. X and y intercepts. The x-intercept is where the line crosses the x-axis. So if I made myself a little picture down here, and I make a line where the line is crossing the x-axis right here, that is the x-intercept. And that always happens when the y value equals 0, because that's where the height of the line is 0, so meaning y1, 2, 3, 4, 5, that sort of thing. Well, when the y value is 0 is on the x-axis, that is when this x-intercept happens. And the same thing is true for the y-intercept. The y-intercept is where the line crosses the y-axis, so here, and that always happens when the x value is 0. Those will become important because when we do our graphing, those are 2 easy points to graph, very easy. In fact, they're probably the easiest on the out of the entire graph to find. So we're typically going to look to those x and y intercepts first, and if we need to plug in some other points, we'll do that. So the first thing we're going to do before we even get to graphing is we're going to find some solutions. So it says here, we're going to find the solutions of an equation in two variables. Notice it says solutions. There is more than one answer here. In fact, for most of these, and all of these I think today, there's going to be an infinite number of solutions. It's not just like x equals 5. It's, well, if x equals 5, what does the y have to be to still make this thing true? And the two variables have a relationship that will always make this thing true. And the directions say fill in the table below to find the solutions of the equation. Alright, so basically the way this works out is you start by picking some random numbers. Now, the easiest numbers to always try, and this will be like your x variable and your y variable. So it's our little t-chart. I'm always going to start with an x value of 0 because that's easy to plug in. What we're going to do is we're going to take this value, plug it into this equation, and do the math and see what we get. So if you have scrap paper off to the side or on the back, or wherever you want to do this in workspace, so we're going to plug some numbers in. So 2 times 0, that's my x that I just plugged in here, plus y equals 2. So if we do this math, if we get this y variable by itself, we'll know what this number here is. We'll have like y equals play pretend, y equals 5. And then we'd say, oh, well, if when the x was 0, the y was 5, and we plug that in. Now, let's see what the y variable actually is. So 2 times 0 is 0 plus y equals 2. And there's no use of having a plus 0 here. So we really just have y equals 2. That was pretty easy, which was the whole point of plugging in 0 for x in the first place, because it made our lives easy. So we have now found one solution to this problem. We found the solution when x is 0 and y is 2. If this is 0 and this is 2, this side equals this side. And that's what we found. That is a solution because it's true. And we're going to find a bunch more solutions. So I'm going to change. And now we're going to say, well, what happens if you plugged a number in for y? And the first number I'm going to plug in is 0 because it's going to be easy. So I'm going to take my same equation, the original equation up here, 2x plus y equals 2. Now, in case of y, I'm plugging in 0. Now, again, if you have something plus 0, that plus 0 doesn't matter. If you add 0 to anything, it doesn't change what the number is. So I can almost kind of like ignore that he's there. That plus 0 is gone. So I have 2x equals 2. Divide by 2 on both sides. X equals 1. So if I have a 1 in for x and a 0 in for y, this stuff equals that stuff. It's true. 2 times 1 is 2. 2 plus 0 is 2. Aha! So the two sides of the equation are still the same. I now have found 2 solutions to this equation. Now, I have 2 more boxes here. I have 3 more. No, 2. I have 2 more boxes here. So we're going to go through and we're just going to pick some other random numbers. It really does not pick it. Yeah, it doesn't matter what numbers you pick. You could pick decimals and fractions and positives and negatives and any other real numbers you wanted. They can be irrational numbers. You put in pi. Now, if you put in pi, it's going to give you a really ugly number for an answer, but it would still work. So typically what we do when we're trying to do these problems is we pick numbers that are easy, numbers that are small, numbers around 0. Now, I personally like to have some positives and some negatives. So I'm going to start with an x value. I'm going to have, what happens if my x value is, I don't know, say negative 2. I just made something up. So if my x value is negative 2, I plug negative 2 in for the x, plus y equals 2. Okay, and now let's see. I'm just going to get the y variable myself. I'm going to solve this equation. 2 times negative 2 is negative 4. The way we get rid of a negative 4 is by adding 4. y equals 6. There we go. So if the x value is negative 2, the y value has to be 6 in order for this to be true, the original equation to be true. Okay, so we made up an x value. Let's make up some random y value. And feel free to try one on your own. You don't have to stick with what I'm doing here, but I'm just going to make up another y value. I'm going to use a positive. Let's say 4. No, because that's 6. That's 2. It's be simply in between. How about y value of 10? I don't know. Just trying to think of something. So 2x plus 10, that's the y value we just made up here, equals 2. And we want to know what x value would we have to get to make this thing true. So if I solve my equation, I subtract 10 on both sides. 2x equals 2 minus 10 is negative 8. Divide by 2, divide by 2, x equals negative 4. And there we go. We have a table of values. Each of these is a solution. So we have 1, 2, 3, 4 we came up with, but there's an infinite number more. I could have plugged in an x value of 5. I could have plugged in an x value of 4.3 and 4.4 and 4.3267 and still found the corresponding y value. I could have plugged in a y value of 1/2 and a y value of negative 2/3. Every single number you plug in has an answer for the x and the y. So if you plug a number in for x, if you solve your little equation, it will spit out an answer for the y. Letter B. I'm going to erase this middle stuff. So we're going to start the same place we did before. I'm going to start, well, our x and our y, and I'm going to start with plugging 0 for x and 0 for y. Those are the easiest two to start with. So we're going to start there. I'm going to say, what happens if the x value is 0? So if this x value is 0, remember, it's kind of like this piece doesn't even exist because negative 2 times by 0 is just 0, and 0 plus 2y is just 2y. So if I'm plugging in 0 here, I don't even need that piece. But I'll write it for a second. All right, so if I plug in 0 here, this piece cancels out. 2y equals negative 6. It cancels out because it's just equal to 0. Divide by 2, y equals negative 3. Okay, I'm going to plug in this 0, so the same equation, 2x plus 2y equals negative 6. All right, now in this case, the y variable is 0, so this whole piece, 2 times 0 is 0. It cancels out, so that piece is gone. So I have negative 2x equals negative 6. Divide by negative 2, divide by negative 2, and x equals 3. So I found now 2 points. I found this is the x and y intercepts. Well, I should say this is the y-intercept. This is the x-intercept. The x-intercept happens when the y value is 0. The y-intercept happens when the x value is 0. So this is where the line would cross the y-axis. So if I made a little quickie sketch here, the line's going to cross at 0, negative 3, and the line's going to cross at 3, 0. So this line, this letter B, is something that looks like that. And I can tell just from those 2 points. Now, it's always better to be more accurate, and the more points you graph, the more accurate you are. Now I'm going to leave my little quickie sketch over here, just so when we come up with our next 2 points, we can check to see if it looks like it will fall on that line. All right, so I'm going to pick an x value kind of in between here. I'm going to pick, say, How about 1.5? We didn't do a decimal yet. Let's plug in a decimal. Let's see what happens. I don't know what's going to happen. Well, probably going to get a decimal answer, but let's see. So if I plug in 1.5 for x, so negative 2 times by 1.5 plus 2y equals negative 6. Alright, so this gives me negative 3. Add 3 to both sides gives you 2y equals negative 3. Divide by 2, divide by 2, y equals negative 1.5. So I showed you right there, even plugging in a decimal, whatever you plug in for the x value, there has to be a y value that would make that statement true, and there it is. Okay, what y value do you want to plug in? I don't know. How about a y value of negative 4? Nah, yeah, how about positive? A y value of positive 4. Let's see. So we checked what happens when the x value is here. We said the y value is here, which would be now. That's 1.5, negative 1.5 would be right there. What happens if the y value is 4? Like 1, 2, 3, 4. Where is the line over there someplace? I don't know. Let's figure it out. So negative 2x plus 2y equals negative 6. The y value is 4, so this piece equals 8. Subtract 8 on both sides. We're solving the equation. Let's see, that gives that cancels out. Negative 2x equals negative 14. Divide by negative 2 on both sides, and x equals 7. So when the y value is 4 up here, the x value is 7, kind of off the screen here a little bit. Okay. So you're kind of getting the idea of how these work. You pick any number for x, you plug it in. If you solve the equation, it gives you the value for y. The same thing is true vice versa. If you take any number for y and you plug it into the equation, if you solve the equation, it will give you the corresponding value for x. And then these pairs, they are pairs, they go together, they're connected, they're related. These are points on a graph. I mean, 0, negative 3 is right here. So this is that point. 0, 3 is that point. Negative, or 1, negative, yeah, 1.5, negative 1.5 is that point. And then these points together give us a picture of what this equation looks like as a graph. What I'd like you to do is letter C. So in this letter C, you're going to do the same thing. You're going to take this equation, 4x minus y equals 0. You're going to plug some numbers in. You're going to find some solutions for the x and the y. Go ahead, pause the video, do it right now. When you're ready to continue, hit play, and we'll go through it together. Alright, so let's see. You probably started doing the same way we did before. X, y, 0 here, 0 here. So if we plug in 0 for x, let's see, 4 times 0 minus y equals 0. So this piece is 0. It cancels out. Negative y equals 0. And technically, this is a negative 1. So we have to divide by negative 1 on both sides. But we're still going to get 0. So when the x value is 0, the y value is 0. Okay. What about our second point here? So if the y value is 0, so 4x minus 0 equals 0. So that's this one. This piece, minus 0, it's not taking anything away, it's just nothing. So I have 4x equals 0, divide by 4, x equals 0. Now that makes sense, right? Because if the x value is 0 and the y value is 0, here, this point is the same thing as that point. That's still the origin of our graph. But now we've confirmed it. That line goes through the point 0, 0. Okay, so that really didn't do a whole lot for us. We have the origin. So let's get some more points here. So we'll make up some numbers. How about, I'm going to pick a positive x and a negative y, just because. So let's say 3x and, how about negative 3y? Let's see what happens. So, for the first one, if x value is 3, 4 times 3 minus y equals 0. This is 12. So we'd subtract 12 on both sides. We're solving our equation. This cancels out. Negative y equals negative 12. Divide by negative 1 on both sides to get rid of this negative here. And y equals 12. Okay? And what happens if the y value is negative 3? So if you have 4x minus a negative 3 equals 0. Minus a negative 3 is the same thing as plus a positive. So I'm just kind of simplifying is what I'm doing. This looks easier than minus a negative. And we solve. So you get rid of the add and subtract. 4x equals negative 3. Divide by 4. X equals negative. Well, you could leave it as negative 3/4 or negative 0.75. Either way works. I'll use the decimal. So there we go. We now have 3, because these two are the same. We have 3 coordinates, 3 points of this line, 3 answers, solutions to this equation. Now the next thing we're going to do, it says here we're going to graph an equation in 2 variables. We're going to take those previous 3 problems we just did, all of these tables we just made, we're going to take those tables and we're going to graph them. And then we'll answer this question afterwards. So how about this? I'm going to move him down. I'm going to take this first one, grab all this stuff, including that, group it, copy it, and paste it. That way I don't have to keep flipping back and forth between the pages. So my first example here was this. I'm going to draw this one in blue. So A is blue. Alright, so I'm just going to start graphing these points. So if I go to point 0, 2, 0, 2. That, by the way, is the y-intercept, because you see how it's crossing the y-axis. I don't know where this line is going from here. I don't know if it's like this or this, but I do know it's crossing the y-axis. Our next point, 1, 0, 1, 0. That's the x-axis. And that, honestly, right there, is enough to graph this line. If I connect these 2 points, and I'm going to extend the line a little bit, that is what this line is going to look like. I bet the rest of my points, these other points here, are going to fit on that line. But it's more accurate the more points you put. So let's see, negative 2, negative 1, negative 2, 6. 1, 2, 3, 4, 5, 6. See, my line was a little bit off there. So having that extra point makes it just a little bit more accurate. Negative 4, 10. Negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. And I can make the line blue and change some properties of the line. Maybe a little bit bolder. Nah, I don't like that. Something like that. So this is the graph of this first equation. 2x plus y equals 2. That's what it looks like. Okay. So now I'm going to grab the second table that we filled out, this letter B here. So I'm going to take all of this stuff, group it, copy it, paste it, drag it over here. We'll do letter B in red. So B is red. All right, so we're going to do the same thing. We're going to start just graphing our points. So 0, -3. 0, -3. That is the y-intercept because that's what's crossing the y-axis. 1, 2, 3, 0. X-intercept. It's where the line is going to cross the x-axis. And just like before, I could make it red. I'm pretty certain now that my line is going to go, or my points are going to go through about that line. Something like that. But let's keep going. 1.5, -1.5. So 1, 1.5, -1, -1.5. Yep. 7, 4. Let's see. 7 is up, so, or I'm sorry, 7 is to the right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So as you've seen, and this is something that's kind of important for geometry, a definition, is that you can make a line with just 2 points. 2 points determines a line. Now these other points that I've made here kind of help reinforce the line, making sure it's true. But it only took 2 points, the x and the y intercepts, to give us the line that we have here. Alright, so that guy's gone, and let's find the letter C, the one you folks did. I'm going to grab all of this, and group it, and copy it, and paste it. Drag it over here, and that guy didn't show up. What was he? 12. Alright, and we'll graph this one in green. So C is green. Alright, so same thing. So we know these first 2 points go together. They are just the origin right here. We've got 3, 12. 1, 2, 3. This is 10. So we're going to have to kind of make some guesses. So 10, 11 would be like here. 12 would be like here. That's not that great because I'm having to make a guess. Now, I can still kind of draw my line in there and make a prediction. Let's see, where's a good green? How about that one? Yeah, it works for me. So I'm still able to make a prediction based off those 2 points, but I don't know how accurate it is because this is just a wild guess. How about this other one? -0.75, -3. So -0.75 would be like in this area. 1, 2, 3. So my guess was pretty good because that -7.5, -3 happened to be right on that line as well. Now, if you're not confident that your line is accurate, feel free to plug in some more points. There's nothing wrong. There's nothing saying, oh, you could only use 4 points. In fact, the more points you use, the better. So if I take some of this and maybe say, I don't like this line C. I don't think it's very accurate. Maybe I want to plug in another point or two. So I might make a prediction. Maybe if I go an x value of 1, 1, 2, 3, 4. So I think if I plug in x value of 1, I should get a y value of 4. I don't know. Let's try it. So the equation was 4x minus y equals 0. Is that right? Yeah. So if I plug in x value of 1, I think I'm going to get a y value of 4. Let's see. 4 minus 1 is 4 minus y equals 0. Okay, so I simplified a little bit here. Now I'm going to solve. I'm going to subtract 4 on both sides, giving me negative y equals negative 4. Since this is a negative 1, I'm going to divide by negative 1, because we have to get rid of that negative. And y equals 4. It's exactly what we thought we should get, based off of the graph. We said if you go 1, 4, we should get a point on our line. So you can continue doing that and get more and more and more points to make your lines more accurate, to make sure that you are correct. Now, this then brings us to our question I had up here earlier. So based on the previous 3 problems, what can you predict about the graph of an equation in standard form? So what seems to be the trend with the 3 problems we did? Take a second, pause the video, go back, review the problems if you need to, review the graph if you need to. What do you think is the trend here? Okay, so hopefully you noticed that all the lines are straight lines. That's actually the trend. There are graphs eventually that you'll get to, not in this class, that are kind of curvy lines. They go like that, or they have little, it's called a parabola, this shape. Well, that doesn't happen here. These are not linear. They do not make a straight line. All of the graphs that we have done here today are linear, because these are linear equations. This is the equation of a line. So when we graph it, we get a straight line. So every equation you get in standard form, well, I should say not every. Yeah, every equation you get in standard form will be a line. I was trying to think if there's an exception to the rule someplace down the line. I can't think of it off the top of my head, but I'm always hesitant about saying every equation. So what we're going to do now is we're going to look at some other types of lines. I mean, we saw how to do graphs like this. You take your x and y values, you plug in some random x and some random y's, you get those values, and then you graph them. That's how we got those points on the lines. But what happens if you have something like this? My equation here is just x equals 3. Well, we're still going to make an xy table, so x, y. The problem is, if we start going through and trying to make up some, like a random value, so say, well, before we did this and this, well, this one right here, it's not even true. We can't plug in 0 for x if we get 0 equals 3. That doesn't work. That's not true at all. So we can't even do that the way we did before. Now, essentially what this is saying that x is 3. Always. No matter what you have for the y value, the x value is always 3. So 3, 3, 3, 3. The x value is 3. Now, what can you plug in for the y value? The answer is anything you want. You could put in a -1 and a 0 and a 4 and a 8. Doesn't matter what you plug in. You can plug in decimals. You can plug in fractions. Hey, that one's now 0.8 and 4 over 5. It doesn't matter what you plug in, because as long as the x value is 3, that is this line. So let's graph this. Let's see what this particular line looks like. If we have an x value of 3, so 1, I'm graphing this first ordered pair, 3, comma, -1. 1, 2, 3, -1. 3, comma, 0. 1, 2, 3, 0. Do you see the trend? If you would connect these 2 points, we would get a line that's going straight up and down our coordinate plane. Let's keep going. 3, 4. 1, 2, 3. 1, 2, 3, 4. Now there's no mistaking it. I've got 3 points along the same line. That's guaranteed to be my line, but I'll keep going. 3, 8, 4, 5, 6, 7, 8. If you plugged in a -4 and a -8 and a +1, you're just going to get more and more points on the same 1, 2, 3, 4. More and more points all along that same line. So our line is here. This is the line x equals 3. And our line should have arrowheads there. Because this line does keep going. That's why we have these arrowheads on the end. It shows this line keeps going forever, never, never. It doesn't stop at -8. Because what if somebody plugged in, say, a -82? Well, someplace way down there, there's going to be a -3, -82, and it's still on the line. Letter B. Y equals -2. So we have our x and our y. So just like before, when we had here, it says x equals 3, we knew that the x value was always 3. It could not be anything else. Well, in letter B, the y value will always be -2. It cannot be anything else. So the first thing I'm going to do is I'm going to plug -2 in for y. Now, as far as what the x values can be, the answer is anything. I can make up any numbers I want. I usually pick a couple negatives and a couple positives. I usually pick easy numbers, whole numbers, but there's nothing wrong with decimals and fractions and everything else. So I like 0. I like, how about -2? How about +4? And how about -6? I don't know. Just picking up some numbers. So 0, -2. Okay, so I don't know what this line's going to look like yet, but I know this is the y-intercept because the line's going to cross right here. Okay, and we go for our second point. -2, -2. So -2, -2. 2 points make a line. I'm pretty sure now I know what my line's going to look like. I'm pretty confident my line is going to be going this way with arrowheads. But let's keep going. 4, -2. 1, 2, 3, 4, -2. Okay, that's just supporting my hypothesis, supporting my idea. -6, -2. 1, 2, 3, 4, 5, 6, -2. Further supporting the hypothesis that this line is just horizontal going this way. This is the line y equals -2. Just like this is the line x equals 3. So we have these horizontal and vertical lines as well. If you could please, I would like you to do these 2 problems. So you're going to fill out the table, complete the table, and graph each of these. You're going to graph them on the same graph space as the previous 2 problems on your paper. Go ahead, pause the video, do it right now. All right, so let's go. X, Y. The x value has to be -7 because the x value is always -7. If you plug some other number that's not -7 in here, it's not true. So this has to be -7. Now, there's nothing that says what the y values have to be. There's nothing that says the y values have to be big or small or positive or negative. Nothing. So the y values could be anything. So I'm going to pick my normal couple ones I pick. I usually pick a 0. How about a -2, a 4, and just to be different, how about a -7? I don't usually pick 7s much. So okay, let's go. -7. 1, 2, 3, 4, 5, 6, 7, 0. Okay? So based off the previous 2 examples, my line's either going to go straight up and down or sideways. Let's see. -7, -2. -7, -2. I now have a hypothesis that my line is going to be a straight up and down vertical line right there. My guess is that because that's what the previous problems have told me. -7, 4. -7, 1, 2, 3, 4. Supporting -7, -7. -7, -2, 3, 4, 5, 6, 7. So this is the line x equals -7. Finally, letter D. X, Y value is 5. If you plugged anything other than not 5, it's not true. The only thing that you could plug in for the Y is 5. The X values, though, they can be anything you want. So let's make them anything we want. I'm going to throw a 0. Feel free to pick some other numbers. Well, you did this already, so pick some numbers. I'm not going to use even. I'm going to use 1, -1. Ooh, change things up a bit. -3. I said I wasn't going to use even numbers. That's hard for me. And how about ooh, how about just 9? I like that. So we go to 0, 5. 1, 2, 3, 4, 5. Y-intercept, by the way. It's where it's crossing the y-axis. -1, 5. -1, 5. -3, 5. You see the line? Yeah. 9, 5. So I have a horizontal line right here with arrowheads. So that is the graph of the line y equals 5. This line, everywhere on this line, all the y values are 5. I pick this point right here, the y value is 5. That point over there, y value is 5. So that's what it's saying. This is the line just made up of thousands of itsy-bitsy little dots. If I would go through and I just keep making dots in here, right there are 5, y value 5, y value 5, and I keep going, all of these points, and I'm missing it, but all of these points have a y value of 5, and if I keep doing this and I keep plugging in more and more and more and more points, you see it's looking more like that line that I just deleted. And eventually, if you get all of those points, you get hopefully a straighter line than I just made, but a line of all of the values where the y value is 5. All of the points where the y value is 5. So how could you tell if the graph will be vertical or horizontal or diagonal, slanty? So how can you tell if the graph is going to be one of these or a slanty like those? Basically, the first type of problem we did or the second type of problem we did. How can you tell the difference? Look back at the problems and what do you notice? Okay, so what did you notice? You might have noticed that for our horizontal and vertical lines, you only had one variable. One variable gives you a one-dimensional line. The line is either going straight up and down or straight horizontal. A equation with two variables, 2x minus 5y equals 3, whatever. Two variables gives you, it has some up and down, but it also has some sideways to it. It goes in two dimensions. Two variables, two dimensions. One variable, one dimension. And actually I mentioned earlier, if you have like an x plus y plus z equals 0, whatever, that is an equation in 3 dimensions. You actually have this other axis that comes out here. And so you could have this three-dimensional, well, I guess it should be a straight line. This three-dimensional line that has both x, y, and z coordinates. So the number of variables tells you how many dimensions the line is in. Okay, so here's example 4. It says Steve graphed 3 points of an equation, negative x plus y equals negative 2. Okay, so that sounds important. Then he drew a predicted line. So Steve graphed, those are the 3 points, there's this table here. Those are the 3 points, and then he predicted that this is the line that goes to those points. I mean, it does go through the points. We want to create a table of points and explain why Steve's graph is not correct. Okay, so what we need to do is we need to become more accurate. Steve just used those 3 points, so we're going to pick some other points that fall in line here and kind of show that it doesn't swerve way out here, way out there. So I'm just going to pick some points not used already. So I have not used an x value of 2 or an x value of negative 3. I haven't used a y value of negative 6 or a y value of, what's that, 3. We'll just start there. So my equation, negative x plus y equals negative 2. If I plug 2 in for x, it gives me negative 2 plus y equals negative 2. So this is just negative 2. So I'm going to add 2 to get rid of it. I'm solving my equation. Y equals 0. So if the x value is 2, the y value is 0. So already we've proven it wrong right here. We know that it should be down here. Okay, so let's pick another point. Negative 3. So I have negative 3 plus y equals negative 2. A negative 3 is positive 3. Minus 3 on both sides, y equals negative 5. So the point negative 3, negative 5. Negative 1, negative 2, negative 3, negative 1, negative 2, negative 3, negative 4, negative 5. So we've proven it wrong right there. So every point that we put in, we're showing that his equation, or the graph that he made, is not quite right. I'm going to erase these 2 and do my next 2. So I'm going to plug this negative 6 into the equation. So negative x plus y equals negative 2. So there's my negative 6, there's my negative 2, and there's my negative x. So I'm going to need to add 6 to both sides. Give me negative x equals 4. Divide both sides by negative 1, and x equals negative 4. So I have the point negative 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So that point actually looked correct. Good job, Steve. Alright, 3. So negative x plus y equals negative 2. If the y value is 3, we're going to subtract 3 on both sides. Negative x equals negative 5. Divide by a negative 1 on both sides, and x equals a positive 5. So we have an x value of 5, 1, 2, 3, 4, 5, y value of 3. Okay, I think to make this a bit more accurate, we need more points like in the middle here. So I'm going to pick another x value. I'm going to delete these. I'm going to pick an x value of 1. And I don't know. How about an x value of negative 2? I'm just looking at where this, I think an x value of 1 would be around here based off my other points, and an x value of negative 2 would be like right there. So those are my predictions based off of the line. Let's see how well they work out. negative x plus y equals negative 2, negative plugging in 1 plus y equals negative 2, add 1 to both sides, we're solving the equation. So y equals negative 1. X of 1, y of negative 1. My prediction was correct. Second point, I'm predicting that if I plug in a negative 2, I'm going to get a y value of 1, 2, 3, negative 4. Let's check. Negative x plus y equals negative 2. If I plug in a negative 2 for x, negative 2 is positive 2. I'm subtracting 2 on both sides to get rid of this add by 2. And y equals negative 4, just like I predicted. So that's going to be that point right there. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 points on this line. I don't think Steve could justify his ugly line here anymore. It kind of has to be like this. Now, if Steve went back and said, whoa, how do you know in between like these 2 points it doesn't zigzag and zig and zag like this and be some weird line? I could come back and say, well, we could plug in some more points. I could plug in 1.5. 1.5 would probably give me that point there. And if I plugged in 1, 2, 3, 3.5 would give me right here. And we could keep plugging in more points in between these other points to make our line as accurate as Steve wants, to prove him wrong that this line does not ziggy-zaggy, that it does go straight the way we have it. So that would be the line of the equation negative x plus y equals negative 2. Summary question asks, how do you graph an equation in 2 variables? Go ahead and do it right now. So here I have, it says to graph an equation in 2 variables, you start by making a table of values. These values are the solution to the equation, and they are coordinates of the points on the graph. So after you've made your table of values, you graph the points, making your line. This has been lesson 4.7. Thank you for watching.